Good morning, everybody. Welcome to class this morning. Thank you for watching, whether you're watching with me live or you're watching later on the recording. Thank you for taking your time to watch this. Hopefully it will really help you a lot to advance and progress in doing your programming as you're approaching your programming assignments and various other things with Java. So, before we get started here, just a couple quick announcements. Really, they're more reminders than announcements. One is to remember to check out that feedback. You know, I try to put feedback with every lab assignment, even if it's just a, hey, you did good, that's something that, a little bit of encouragement can be validating and help you keep on progressing and keep on going further. So, like, even if you do well, like a little bit of, well, way to go, you did good, can go a long way. I might have some ways where you could have made your code a little more efficient. But especially like if you made less than 100, you definitely want to check out those the feedback just to see, where you went wrong, what you could have done better, and all that kind of stuff. So remember to check that. That's in your gradebook. If you go to the My Grades section of the course, beside the grade, you'll see a little speech bubble. And that is the feedback for that assignment. Also, don't forget to check out that tutoring opportunity if you feel like you need it, that I posted about this past Friday with our weekend reminders. I was unaware that that existed before last week. And now that I found out that you guys could actually get help through tutor.com, have a one-on-one tutoring opportunity, even though it's virtual, that could go a long way to, giving you some help in some certain situations. So really cool opportunity. So make sure you're taking advantage of that when and if you need it. But this week we're talking about conditionals, and we have a lot to talk about conditionals. So we are going to really need to go ahead and jump right in, not dilly-dally around this any longer. So we're talking about conditionals today. And so when I say the word conditional, or when I'm talking about a conditional, I think the first thing that it's important for us to kind of discuss is, well, just what is a conditional? So what is a conditional? So you might have been programming before, doing some this and that with some code, and you hear about something called an if statement. And we can also call a conditional an if statement. The big goal behind our conditional is that we need our program to be able to make a choice. And this is where this is the point where our programs are starting to get more advanced, smarter, more useful. Because we're giving our computers, via our programs, the opportunity to make a decision, which is enormous, right? When we think about, the fact that we're telling our computer some decisions to make, and, well, we have to establish some criteria on which these decisions can be made. So in establishing these criterias, we basically set up a kind of a mathematical statement, right? We're setting up this statement that we need to evaluate. In symbolic logic, we might call this a proposition, a unambiguous statement that either evaluates to true or false. Right? So as we're approaching these conditions, these mathematical statements, we need to make sure that there's something that can be evaluated to be either true or false without any ambiguity. Because really, at the end of the day here, what we're going back to is this whole idea of binary, right? Even though we're giving our computer some decision-making opportunities here, the ability to make decisions here is still limited. right? So we're using this Boolean logic, this true or false, this 1 or 0, to be able to allow our computer to make these decisions based on the conditions that we make. Now, we establish these mathematical statements with relational operators. And relational operators are used to check conditions like whether two values are equal or whether one is greater than another. So if you've done a little bit of algebra in school, you're probably familiar with some of these operators. Things like greater than, less than, greater than or equal to, less than or equal to. These are our mathematical symbols that help us evaluate our conditions. And based on these conditions, we can determine whether something is true or false. See, it's as simple as that. So when we look here, we see a list of our relational operators. One of the things to note here is our first relational operator here at the top, the equals equals. It's two equal signs. And that would suggest that x is equal to y, and causing our computer to make a decision based on whether or not that's true, based on whether or not value 1 is equal to value 2. But as we're approaching this equal relational operator, we need to make distinction between our double equals sign and our single equals sign. Right? We talked about our single equals sign in relation to variables. Our single equals sign is for assignment. When we utilize a single equal sign, that is for assignment. That says that whatever we call this variable is whatever we are assigning to it as a value. So if we say x equals 5, and then we print, system.out.println x, we get 5. Which is different from our relational operator, because what that's doing is that's checking to see if this one value is equal to this other value. So with one equal sign, that's assignment, that's saying make this equal. And with two equal signs, that's checking to see if one thing's equal to another. So if we utilize this same scenario where we have established a variable of x as 5 at some point, and then later on in our program, we check to see if x equals 7, well, that is false. Because x, not 7, x is 5. So that's a big distinction that we need to make as we are writing our programs. That's something that we don't want to get confused, is this whole idea of equals versus equals equals, assignment versus evaluation. Right? We can see the rest of our relational operators here, not equal to, with the exclamation point equal symbol, greater than, less than, greater than or equal to, and less than or equal to. These are all conditions that we can check, one number or one element versus another element, to see if they're the same. Now these relational operators are for primitives, doubles, integers, characters, those primitives that we talked about earlier on when we were talking about primitive data types. So we can use these relational operators to evaluate any primitive against any other primitive. Now, one place where we can't use these relational operators is, if you'll remember back, we said before that strings are not primitives. And, we kind of remember this by the way that we declare a string variable. We declare a string variable in a massively different way from the way that we declare the rest of our other variables. We use that string object, that string constructor object, to create that string variable instead of just the standard variable creation process that we use for everything else. So when we're relating strings, when we're evaluating strings, we have to do it in a much different manner. So if we want to check the value of a string in a condition to see maybe if a user entered something that we expected them to enter, we need to use the dot equals method. And so in just a little bit, we'll do some examples of all of these types of conditionals, and we'll include this one in here as well, so you can see the difference between just a standard condition and this type of string conditional where we have to use our dot equals method to be able to relate the string to another string. We also have logical operators that we can use in our conditional statements, and these are so that we can evaluate multiple conditions at one time. So like my example here is that if I want to check to see if a number is between 1 and 9, for example, which is what we have here, I might want to check it to see if it's between 1 and 10, which we'd have to do this a little bit differently. But my example here is to check to see if something is between 1 and 9, if it's a single digit integer greater than 0. So what we have here is we have two conditional propositions here, two statements that we can evaluate with the ampersand, or and in between them, and that is a logical and. So that means that both conditions have to be true in order for this statement to evaluate as true. So when I'm looking at this conditional statement here, I see that x is greater than 0. So if we evaluate that as, just what we know based on logic, and we say x is greater than 0, we know that that would put, if that part of the statement and that part of the statement alone was true, that would mean that x is anywhere between 1 all the way to infinity. And if we were to look at our other statement here, where we're saying x is less than 10, well, that would mean that x is anywhere from 9 all the way down to negative infinity. All the way from negative infinity to 9. So this and logical operator here means that we have to have some condition, some input where both of these conditions are true. And so we can kind of see what this means here. We'd have to have a number between 1 and 9 for this condition to be true. Because if it was, if it met this first condition, if it was like 10, right, that meets this first condition, but that doesn't meet this second condition because 10 is not less than 10. 10 is equal to 10. So 10 does not meet this second condition. So if 10 was in there, even though it meets the first one, it's going to be a false. If it's something like -5, right? -5 meets this second condition because it's less than 10. But it doesn't meet this first condition because it is not greater than 0. So the only numbers that would allow us to evaluate this statement here as true would be the numbers 1 through 9. So this is a good way to kind of narrow down, to kind of isolate a set of numbers or a sequence that we can kind of work with a little more. Right, and we have other logical operators here. We have the bar, which is that symbol that's right above your enter key on your key. Hold down shift and you hit that key. That gives you that straight up and down line. That's what that symbol is there for or. So in that condition, we're basically reading it as we would in English. We would say condition A or condition B. So if either one of them was true, then the statement would evaluate as true. And then we have our exclamation point as our not operator. And our not operator kind of negates the relative comparison. So if I say that it's not equal to 7, then it could be any number that's not 7. Would evaluate to true as that statement. So let's go ahead and look at a conditional statement example here. And then actually move on to writing a little bit. So we have a code example here at the top where we are given this condition of if x is greater than 0. So if x is any number between 1 and positive infinity, we can say that this is true. So when we're thinking about conditionals, right, and we're thinking about having our terminology correct, the statement that's located in our parentheses here, that's the part that is the condition. And if this condition is true, then it proceeds to the next thing, which is to run the code that belongs to this condition. And so as we were doing with our methods last week, if we have code that belongs to a specific method, we wrap it in our braces. So likewise, if we have additional code that belongs to a condition, we wrap it in these braces. And so we say that this code here, that's inside these braces that are immediately following this condition, belongs to this condition. So if this condition is true, then it will execute this code. But if this condition is false, then it will skip over this code. And so the flow of execution in that sort of way starts to look like a tree. It gets this little tree data structure to where, based on the decisions that our program makes, the interpreter is going to go one way or another, and there might be some blocks of code that are in our program that never get touched because the condition does not evaluate to true. So let's write a little program ourselves that kind of takes advantage of this. We start off just looking at if statements. We'll talk about adding else if and else statements to these in just a moment. So we'll kind of take what we're kind of doing here and build on it as we progress throughout our time today. But let me just open up the REPL that I have here. All right. So what I'd also like to do in addition to this is go ahead and practice some of the stuff that we were doing last week and the week before as well as we do this. Because remember, this stuff kind of snowballs. Each week we're adding more and more to what we know. So the more we do, the more we practice, the more we use the past things that we've learned. So in this condition, what I'd like to do is I'd like to kind of just do basically what that program was looking at for us to do there, in creating a program where we can get a number from our user, something from 0 to whatever, or maybe a negative number, or any integer. We can take any integer from our user, and we can evaluate it to see if it is positive, right? So that's a good one. Or maybe let's change it up a little bit, because let's talk about modulo, because we've looked at modulo a little bit before. Modulo is represented in our arithmetic operators as a percent symbol, and it's a way to figure out whether a number goes into another number evenly, because what is represented by our modulo is the result of the mathematical equation, or rather the remainder of the of a mathematical division problem. Right? So I think I've talked about it before, where we've said like 2 or 4 divided by 2 is 2, but 4 modulo 2 is 0, because there's no remainder. And so if there's no remainder, then that lets us know that that number that we're dividing into our other number goes in there evenly. So let's write a little program here to check to see if a number is even, and we will kind of add on to it later to check to see if the number is odd or something else. Right, so let's start to write some code. So I'm going to write my own method here that's going to take my input, and I'm going to write my own method that's going to evaluate my conditions. So now that we've learned about writing new methods, we should be expected to write new methods. So since I'm going to take an input from my user, I'm going to import my scanner class. So that's import java.util.scanner with a capital S in scanner. And now I can start to write my method to accept an input from my user. So if we remember back to last week, that's public static void. We give it a name like accept input. And we can even call it with some kind of argument like message, so that when we MSG, so that when we and this is a string message, so that when we call our function later, we can call it with this string that we want to be our message as an argument. That makes it more versatile. That allows us to use this same method in different programs without having to actually change the method itself. So here we will create an integer variable, int num. We can't assign it a value yet because we don't have the value yet. We're getting it from our user. We also need to invoke our scanner class, make that scanner object so we can have it start to listen. So we can say scanner n equals new scanner system.in. We can system.out.print our message, whatever we put as the argument here. And then we can set the value of num to in.next int. And so this is the basic stuff. We were doing the inputs 2 weeks ago. It's the basic same input logic that we were doing it 2 weeks ago. Now we've just put it in its own function to isolate this inside of its own method. So now what I have here is I have a function or method, depending on what programming language you use. Programming in too many programming languages this semester. In Java, they're methods, so we'll try to keep calling it a method. Now I have this method here that I could just take it. I could take this out. I could copy it and paste it into anything. I could import a class into another file that has this in it. It's fully modular. I wouldn't have to come in here and change whatever my print message is because that's being brought in with the argument. Now I'm going to have to take this data here and send it out to utilize it in another method, right? And since we haven't done value methods yet, we've only done these void methods, that means that I'm going to have to call that other method from inside of this method. So before we do that, let's write that other method. Right, so we'll write ourselves a new method here, and it's going to be another void method. So that's going to be public static void. We'll call this check even, and we'll take an integer of some. We'll call it integer n for number. That'll be the integer that we send it to it from here. Right, so from here we can write our conditional statement. So now I'll slow down just a little bit so we can write our conditional. So we're going to say if, in parentheses, in modulo 2 equals, because we're evaluating. We're not stating an assignment, we're evaluating, so we use 2 equals here. 0. So on the condition where this is true, and n modulo 2 equals 0. So we're saying in the event that we have a number that 2 will go into evenly, what we will do is we will system.out.println the number is even. And so notice here we have these braces. They're immediately after my conditional statement here. Like we can even look and we can see where like these different things go. We have this brace here that closes with this brace here. That creates a pair that wraps the code that belongs to my conditional. And we have this brace here that pairs with this brace here. And that creates my pair that wraps my method. And then I have the other one that wraps my class. So now that we have this function established, we can go back and we can call it in our previous method here, our getInput method. So we can run check even, enter. We can run check even, and we're going to pass it the value of num, because that's going to be what we get from this function. And so now all we have to do is we have to kick things off. And we do that by putting the first function that we want to run in main. So we're going to put our accept input function in main. And then our accept input function is going to run first. And it has our check even function inside of it. So it's going to run that function when it gets to our check even section. So we'll say accept input. And we have this string here, so we can say enter number. Like that. And so that takes that string that we put there, bring it in as the argument. Does its whole thing, so it'll do system.out.print and put that message here. Get the value, do its thing, so on and so forth. So let's give it a try. Enter number. So that's working well so far. So let's start off by doing one that's going to work, right? So if I run a 6, 6 divided by 2 is 3. There is no decimal point. There is no remainder. So 2 goes evenly into 6. So this is an even number. So this should evaluate as true and give us our statement that the number is even. The number is even. So that's what we should expect to happen here. But remember that this code only runs if this condition is true. So what happens if the condition is false? So let's put an odd number in here. Let's run it again. Let's put an odd number in here. Something like 7. So there is a remainder here for 7 because it's, if we do 7, if we do 7 divided by 2, that's 3.5. Or 3 with a 3 with a remainder of 1, meaning that modulo problem is going to be greater than 0 and not equal to 0. So that condition is going to evaluate to false. So if we hit enter here now, nothing happens because we don't have any code in our program for the event that our condition here is not true. So that allows us to kind of go back to talk about some more stuff before we progress and go forward. Because in order to have that condition met, what we would want to do is we would want to be able to chain and nest our conditions. And so ideally here, what we would want is to do with our conditions what we call chaining. So if one condition is not true, we can add another condition in the event that one does not run. And so we do those with if, else if, and else statements. So if we want to check related conditions and choose one of several actions, one of the ways to do that is by chaining a series of if and else statements. And we can see what we have here. Our syntax here is incredibly similar, right? So we're always going to start out with this if condition, and that is the minimum that we need to have a conditional is an if condition. However, if we want to add more, we can add an else if. So else if is like an if, but it allows us to add another specific condition. So in this instance, we're saying, in the example that we have here, we're saying if x is greater than 0, well, then we're going to print that it's positive. Else if x is less than 0, we're going to print out it's negative, because that covers every number from -1 all the way to -infinity. So in the event that our first condition here fails, our computer is going to try the second condition, that else if condition. And then if that's true, it'll run it. If it's not true, if that condition fails, it'll keep moving down the list. And we can write as many of these else if conditions as we want to, or as we need to. Now, the final thing that we have on our list here is an else condition. And our else condition covers everything else. So like in this example here, if x is greater than 0, that's going to cover every number from 1 to infinity. Else if x is less than 0, that's going to cover every number from -1 to -infinity. Our else condition then is going to cover everything else, which in this case is just the number 0, because everything that's not 1 to infinity or -1 to negative infinity is just 0. And so, if we want to add more conditions to this chain, all we have to do is add more else-if statements. And as we, kind of keep going down, we want to make sure that we keep these chains readable, especially if we're adding a bunch of conditions to one of these conditional chains. Because, the more that you add here, it's just a lot of bulk. So, making sure you have spaces, making sure you are tabbing and doing the formatting of your code properly just so you can read stuff is going to help you out in the long run. But now let's go back to our sample program that we're working on here. Pull that up. And let's add another condition to our check even method for some other events. So what I'd want to do to try to make this fairly efficient, what I want to try is I think I want to see if x is 0. And so when we're doing this, we kind of have to think about the logic behind this. Because let's check something in our program before we try this out. What happens in the current state of our program if we enter a 0? Give it a second here for our interpreter to decide to run. We might want to refresh. So let's see what happens here if we enter in a 0, right? We're going to test this out with a 0 as our input. And we get the number is even. So this is one of the important things that we have to consider logically as we use our conditions. Because if I try to write an else-if statement here, checking for 0, else if n equals 0, system.out.println, the number is 0, this isn't going to evaluate 0 to be 0 for me, ever. This code here will never be reached. Because remember, we said that the way conditionals work is that whatever I have at the top of my conditional stack is going to be evaluated first. If that evaluates true, then it's going to run that code, and it's going to go on to, end your program, right? Or do whatever the next thing that you have in your program outside of these conditions are. The first condition that evaluates to true is going to be the one that runs. All the rest of them are just thrown away after that. So even if I run this now and put in a 0, I get told the number is even, not the number is 0. So one of the tricky things here is that I have to be smart about this and decide what I need to evaluate first. So in this instance, I need to evaluate whether or not the number is 0 before I evaluate whether or not the number is even. So if I refactor my code a little bit here, I can set that up. The number is 0. The number is even. So now it's going to check to see if the number is 0 first. And so if it's 0, it'll tell me the number is 0. If it's anything other than 0, it'll move on to the next condition. So now if we run this and enter 0, it'll tell us the number is 0. If we run it again, and we enter in something like 8, well, 8 is not 0, right? So that's going to evaluate false, so it's going to move on to our else if condition and tell us that the number is even. So how do we handle everything else? How do we handle our odd numbers? Because essentially we have 3 classes of numbers here. We have even, odd, and 0. So we have our 0 covered. We have our even covered. So technically we could cover everything else in an else statement, right? So we can just write else system.out.println the number is odd. And now we have that. So if we run it, a 0 evaluates to 0. An even number evaluates to an even number. And an odd number, since the only thing that we have left is odd numbers, well, that evaluates to odd. So this is pretty good, right? This gives us a lot of flexibility, because we're allowed to take these else if statements and chain as many of them as we want. But what if we want something to happen only when one of these other conditions is true? What if when we have one of these decisions and it evaluates to true, we want our computer to make another decision? Well, in that instance, we would want to nest conditionals. So we can nest conditionals in the same manner that we can chain conditionals. We just put our new conditional inside of one of our old conditionals. So in that sort of way, we can have these conditionals chained one inside of another. Or nested one inside of another to get more complex decisions. Now, also, just like our chaining, nesting is a commonly used technique. We'll use it in just a second. But it can make your program sloppy. So let's head back over to our program that we're working on here. And I'm going to add a condition to another condition to the inside of a couple of my chained conditions here. So what I want to do is I want to check whether a number is large or small. So I'm going to give it another condition inside of these conditions to say, well, it's large and even, or it's small and even, or it's small and odd, or it's large and odd, right? So if I add another if statement inside of here, if in greater than 100, we will say the number is large and even. Else system.out.println the number is small and even. So now remember that this code that's inside of this condition is not going to run unless this initial condition here is evaluated to true. So once this initial condition here is evaluated to true, it's going to run the code that's inside, and it's going to evaluate our number again. So if it evaluates n to be greater than 100, so anything from 101 to positive infinity, that number is large and even. Else, which is going to be anything from 100 to negative infinity, it's going to say the number is small and even. And we can do a similar thing here with our odd numbers. So we can say if n greater than 100, our number is large and odd. Else, system.out.println, the number is small and odd. And we'll add a little bit of formatting here just to make it a little bit nicer, a little bit easier to read. So again, that's going to check these new conditions after the old conditions have run. So if we run this now, we can enter a number like 204, and we're going to get that number as large and even. If we run this now, and we enter something like 76, we're going to get that number as small and even. Likewise for our odd numbers, if we enter something like 55, well, that number is small and odd. If we enter something large and odd like 501, well, that number is large and odd. And of course, 0 is still 0. So this gives our program the ability to make some complex decisions. And really, in a nutshell, this is what you need to know for our program. Now, we're getting close to the end of our time, but there's one more thing that's kind of important and kind of complicated that I want to talk about, that I want to make sure we talk about before I end the stream today. And that is recursion. So now that we have these conditions, we can start to do things recursively. And we say here in this title slide that that means doing things over and over and over and over and over again. And it is doing things over and over and over and over and over again in a special kind of way. Right? So if I look here, one of the first things that we want to do is we're going to want to define recursion. And just defining the term recursion on its own can be part of a challenge. You know, problems in every area of life essentially can be defined recursively. And when we say recursively, that means that they are described in terms of themselves. So when we're talking about things being in terms of themselves, and when we're talking about methods like we learned last week, well, gosh, what if we had a way to call a method inside of itself so it just ran over and over and over and over again? Because each time it hit that method invocation, well, it would just run again. Because that's what happens when we invoke a method. So we can kind of look at this idea of recursion in that sort of way, as an item that is kind of referenced in terms of itself. Right? So like if you've ever seen like a definition in a dictionary have the term that it is defining in the definition, you can think of it about it as like a compound sentence. These are two sentences with the word and in between them, two mirrors kind of facing each other, and producing this set of recursive images where they're both reflecting on themselves. So recursion is a thing in real life, but it's also a thing in programming. So as we've mentioned, we say that a method is recursive, or that there is recursion, when a method invokes itself. And what happens here is that method, especially in Java, is essentially cloning itself, putting another copy of itself into memory so that it can run its own program again. So when we're utilizing recursive methods, this requires us to be creative about how we think about solving a problem. So anything that is written recursively can also be written non-recursively or iteratively, which we'll talk about in the near future when we start to talk about loops, and vice versa. And this equivalent doesn't say that it's as easy to do one method or the other, and some problems are more suited for recursion than others. Now, there are 3 laws of recursion. One is that there must be a base case. This base case is established by a conditional, by a condition. There must be a base case that a path through the code, which is a path through the code, which does not call the function again. And this base case is set with a condition. Because what we've seen here is we've seen with our conditions that we have the ability to run code or not run code based on whether or not a condition is true. So we can run code or not run code based on whether or not a condition is true. And so in doing so, there must be a recursive case or a line of code that calls the function from within the function, calls the function from within itself. And in that call, we have to adjust the arguments that we call the function with again, so that we move the problem, move whatever variable we're utilizing, so it's closer to that base case, so that we can eventually have that condition be evaluated as false and stop the recursion. And if we don't do this, we have an infinite loop. And what is an infinite loop? Well, when we're utilizing recursion, we have to use these conditionals to put a stopping point on our program. So we can set up a function to where we can say, while this argument is greater than 0, we can run this code. So if this argument is, if this value that we're bringing in as an argument is greater than 0, we can run this code, but we have to be able to hit 0 at some point. So when we are doing that recursive call, we have to be able to subtract in this case, or add in other cases, some kind of value to that argument before we recall the function, recursively call the function, so as to move that value towards that base case, get the argument that's brought in closer to 0 or closer to the condition in which it will break. Because if we don't, we create an infinite loop. And creating an infinite loop in Java is bad. Because in Java, an infinite loop will crash our program. There are other programming languages that have like infinite loop protection to where everything would be fine. In Java, an infinite loop is going to crash our program. Because it keeps calling the function keeps calling itself over and over and over again, and this takes up more space in the call stack. And none of these function calls ever return, so it just starts eating your volatile memory, just eating that RAM. Just more and more and more RAM getting into the memory until you have an overflow and your program crashes. Which is bad. So let's write a little example here of a recursive function call. And we'll make it fairly similar to this. In fact, you know what I want to do? I want to fork this instead of writing an entirely new function here. And we'll give it a new name here, though. We'll call it Recursion Demo. Because really what I want to do is I want to be able to keep my scanner function here so that I can utilize that a little bit. So I want to keep this input, this function I wrote to accept the input, so I don't have to write it again, which means I can also accept this here. And so what I'm going to do is I'm just going to write a little function to count down. Right, so we will delete everything that we don't need here. Make sure we're leaving that curly brace at the end because that's the curly brace for the class. And we'll write a function here. Public static void countdown int n. So what we'll do is we'll say if n greater than 0, we will system.out.println n. And then the most important part, we will increment our value of n. So what we can do here is we can say n equals n minus 1, or we could use our Java shorthand for that, which is n minus minus. So writing n minus minus is just the same as writing n equals n minus 1. It's just a shorthand. And then our else condition can be to print out system.out.println. We'll just have it print out thank you. And then the other thing that we have to add here is we have to add our recursive call. So we're going to add that to the if statement. So we're going to add countdown n here as well. So whatever value we get put in, which is going to be a value that we get transferred from our user, is going to come in as the value of n. We're going to evaluate that against 0. We are going to print out the number. We're going to subtract 1 from the value of n because that's going to bring it closer to 0. And then we're going to run n, whatever n becomes then, as the argument again. So we can kind of look at it this way. Right? So we have our input. We have our output. And let's say our user starts off with 3, right? 3. So then at that point, n becomes 3. So we bring n in as 3. 3 is greater than 0. So we would print out as our output 3. We subtract 1 away from 3. So at this point, it would be 3 minus 1. So at this point, n becomes 2. And we put 2 in here. 2 is automatically put in here to run again. So at that point, we go to do it again. We get 2. And our input is 2. So 2 is greater than 0. We'll print out 2. And then it's 2 minus 1, which makes this 1 when we recurse the function again. So at that point, our input is 1. 1 is greater than 0, so we're going to print 1. We're going to subtract 1 from 1, which makes it 0. We're going to call our function again, but now with 0 as the value of n. So now our input is 0, and 0 is not greater than 0. 0 is equal to 0. So at that point, this code will not run, and we will get thank you. It's going to run our else code instead. And there is no more recursive method to call here. So it's done. So let's make sure that we have all our right function calls here. Instead of accept input, we will call this enter number to start countdown. And we'll call our countdown function inside of our accept input function. So countdown with the value of num as the argument. So now let's run this. So we're going to enter a number to start countdown. Let's start countdown from 10. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Thank you. Perfect. That's exactly what we wanted. We can put in whatever number that we want as the place to start our countdown, like maybe even 20. And it's going to count down until we break that condition by subtracting 1 enough times from our argument that n is no longer greater than 0. It's going to keep on counting down. And what's great here as well is that we can add even more conditionals to this, right? So we can add some nested conditionals inside of here. For example, we could say if n modulo 2 equals 0, well, in that case, we can system.out.println even else we can just print out the number, and we can keep everything else constant. So now in this case, if the number is even, instead of printing out the number, it'll print out the word even. If it's odd, it'll print out the number. And in the case of an every time, it'll increment the value of n and keep moving on. So now we can try this one. We'll run it. Enter a number to count down. Let's start counting down from just some strange random number like 27. 27 even, 25 even, 23 even, 21 even, 19 even, so on and so forth. And so these are conditionals in a nutshell. And now we've thrown recursion into it to allow us to loop our program over and over and over again, which is of huge significance. So it is important as you kind of take on the following things to have this stuff understood. So that's great. So we've blown past our hour that we normally try to set us out for in these live streams. So with that being said, we'll go ahead and stop here for today. I'll go ahead and turn the music back on, hang out and chat for a couple minutes just in case anybody has any questions in chat. If you're watching this later and you have some questions, make sure to email me, ask these questions. It's all good. But thank you for watching. We'll see you next time.